Today's lesson is section 1.1, Operations on Real Numbers. You can fill out your name, date, and period. The objectives are listed for today's lesson. Find the sum or product of two rational numbers and explain why the sum or product is rational. So if you add two rational numbers, like 2 plus 2, you are going to get a rational number. The sum will be rational. It'll be 4. To get the product of two rational numbers, let's say 5 times 3, you're going to get a rational number, 15. But if you have a number with pi in it, that's irrational. So the second objective, find the sum or product of rational and irrational numbers. And like I said, irrational might be like pi or the square root of a number that is not a perfect square. Like the square root of 5 is irrational because there's not a decimal that or a number that we get when we take the square root of 5. It just goes on and on. So that's irrational. And we'll explain when the sum or product is rational. Imagine an animal shelter. We can classify all the critters in the shelter as a set, and we'll call that set animals. What subsets could exist within the set of animals? Okay, so we have animals. And let's say we go to the shelter and we see a black dog. We see a white cat. We see a white dog. And we see a brown dog. And maybe we see a black cat. And you can say however many animals, but the question asks what subsets could exist within the set of animals. So we could say that there could be the subset cats. And within cats, what do we have? We have a white cat. We have a black cat. And then another subset could be dogs. And you could list all the different kinds of dogs that are at the shelter. Or you could have a subset called black animals. And within that, you would have a black dog, a black cat. So there's many things that you can do with a set and a subset. So the animals is the set, and the cats would be a subset. Could a particular animal be an element of more than one subset? Give an example. Okay, so let's say, like I said, we have cats. And within the cats, we have white and black cats. Could the white cat or the black cat be in another set? Well, let's say that we wanted to list all of the white animals. This would be another set, or another subset, of the set animals. We have white animals, and within that white animals, we have a white cat, and we have a white dog. Now you can see that yes, the white cat is in both subsets. So yes, the white cat is in both subsets. So a subset is something that's within a bigger set. Let's talk more about sets and subsets. So 2.0. We have this problem right here. In the given set of numbers, which elements are in both the subset of numbers divisible by 2 and the numbers divisible by 3? So we're looking at this set A. 5, 6, 7, 8, 9, 10, 12. I skipped 11. That's okay. Right here we'll list the set B. Let B be all the numbers divisible by 2. So we'll list all of these numbers that are divisible by 2. 6, 8, 10, and 12. Let C be all the numbers divisible by 3. So divisible by 3, that would be this one, 6, 9, 12. I'm sorry. Six, 9, 12. Okay, and it asks which elements are in both the subset of numbers divisible by 2 and the numbers that are divisible by 3. So which one are in both sets? And we see that here as 6 is right here, and 12 is also in both sets. So which elements are in both? 6 and 12. And I didn't put a box there for you, so just go ahead and draw a box. The next example is compare and order real numbers. Put the following on a number line from least to greatest. Okay, so in step 1, what we're going to do is we are going to write these numbers as decimals. Okay, so we have 25, the square root of 25 over the square root of 9. So what I'm going to do is take the square root of each of them. You are allowed to do that, to split the square root to both the numerator and the denominator. And we get the square root of 25, 5 times 5 is 25. The square root of 9, 3 times 3 is 9. And we're going to find the decimals. So you can put this in the calculator if you'd like as 5 divided by 3. And that would give us 1.6 repeating. Okay, I'm going to put a comma so we can do 2/3. 2/3 as a decimal is equal to 0.6 repeating. And to get that in the calculator, it's 2 divided by 3. We don't need to do anything to the 1.75 because it's already a decimal. The square root of 12, we would have to put that in the calculator. And that is going to be 3 point something. Bear with me, I don't have my calculator on me at the moment. And 1/4, if you do 1 divided by 4, you get 0.25. You should also memorize this one because 1/4 is 1/4, and a quarter is 25 cents. 12. 3.464. 3.46. We'll just round it. Okay. Put the following on a number line from least to greatest. That's what we're going to do in step 2. So step 2, we're going to draw a number line. And And we're going to start with our smallest number. And I will just circle these for you so you can see them a little bit better. Which one is the smallest? Well, there's nothing that's negative, but they are pretty close to 0. Is 0.6 repeating the smallest or 0.25? Well, let's think about this. This is like 25 cents. If this is repeating, or even if it had a 0, but it's not, it would be 0.66666, is like 66 or 67 cents. That is more than 25 cents. So the least would be the 25 hundredths. So here is 0. I'm going to put, it goes up to 3.46. So I'm going to put 1, 2, 3, 4 so that we can fit all of our numbers on here. 0.25, that's going to be the first one, and it was originally given to us as 1/4. So I'm going to put it on our number line as 1/4, which will be not half, but right here, 1/4. The next number would be the one that I said was like 66 or 67 cents, which is 2/3. So 2/3 be about here, 2/3. It's not quite 1. And then the next number would be the 1.6 repeating, and that would be a little bit more than 1.5, so about here, and we'll write that as it was given to us originally. So the 1.6 repeating was originally given to us as square root of 25/9. Okay, and the next number that we have is 1.75. And that's not quite 2, so I don't quite have enough space, but I'm going to put it right here, 1.75. I'll put it above. And then we have our last number, 3.46, which is a little less than 3.5. And it was originally given to us as the square root of 12. So these questions are requiring multiple steps. And the first step is to write the numbers as a decimal, and then we can compare them more easily. And then we put them on a number line in order from least to greatest. So in order, it would be 1/4, 2/3, the square root of 25/9, 1.75, and the square root of 12.